right, so the first problem, they wanted us, this is data that we've used before. Um, and they just wanted us to use it again. So I'm going to plug it in Desmos because I don't remember all of the specifics. Desmos graphing calculator, here we go. So plus button, table, and then I can just plug my values in, 78 with 485. And then I have 88, 534. 94 with 601. 83, 541. 66 with 197. 101 with 656. 92 with 600. Whoops. 88 with 534. 90 and 587. 80 with 478. Okay, so in order for us to find this, you just zoom out multiple times, and it looks like we start getting it there. So just by investigation, looking at it, we see that it appears to be linear. It appears to be a positive correlation because as I go to the right, it goes up. So that takes place. And let's find our equation. So I'm going to go y sub 1 and then tilde mx sub 1 plus b. And it looks like we have a correlation. We look only at the r, so 0.937 or 0.973 or just 0.94 rounded to 2. Correlation, there's strong positive linear association between high temperatures and the number of visitors at this water park. And so let's go from there. I'm going to write this down. Minus 523.2. All right, so our data will say, who came in? So now we can recognize that we have this equation that would have worked. So y equals 12.14 x minus 523.2. Some characteristics to note. This is our slope. Okay, and slope can indeed be decimal, that's fine. And this is our y-intercept. So state the equation, regression equation. So we would want to have it being y hat equals 12.14 x minus 523.2. Sometimes they might say it this way in statistics, and this is also okay. So either of those is 100% fine. The y would be the visitors, and the x would be the temperature. Okay? So there's different things you could do if you wanted to see how many visitors you'd have when it was 73 degrees. What you could do, or 75 degrees, is you plug in 75, you do the math, and it would come out to this many visitors. Okay, if you wanted to figure out how many there would be with 95 people, you could plug 95 in, 95 degrees, and that would tell us that we have 630.64. And then to what extent do you trust your predictions? Says the correlation shows a strong linear relationship, so we could trust the predictions. Again, it's a prediction. Okay, it's not a conclusion. Predict the number of visitors on a day in which the high temperature is 106 degrees. So this is where we get a little sketchy with it. So if I used 106 degrees, that would give us 764.2 visitors to the park. Would 106 be something that we would want to know? Well, what's my high temperatures that are given on the top of page 143? I have 78, 88, 94, 83, 66, 101, 92, 88, 90, and 80. Do I have 106, or is that outside of my data? It's outside of it. Okay, so being 106 is outside of the data. It's called extrapolation. It should not be a trusted amount. Okay, so anytime you have something outside of your data and you're trying to make a prediction, it should not be trusted. And then on page 144, it says consider the scatter plot. So you have a thing given to you. So it appears that you have a negative slope, so the association would be negative, meaning your R value would be negative. You have weight of a vehicle versus the amount of mileage it gets. So they gave us the equation. So interpret the meaning of the slope in the context of the equation. An increase in weight of 1 pound would, because they gave you the equation, so they're going with this equation. They're saying they're going Y, which is your mileage. So I'm using Y hat. And X is your weight. So if I increased 1 pound of weight, if I plugged 1 in here and I did the math, that would result in me getting this much less mileage. Okay? Because it's a negative correlation. So a truck that weighs 0 pounds, if you have something that weighs 0 pounds, it should get 45.64 miles per gallon. Okay. The y-intercept is an extrapolated piece of data. Okay. Our data does not have anything sitting on the 0 or on the y-axis. It's extrapolation. It's not to be trusted. Okay. And let's face it, we're not going to have a vehicle that weighs 0 pounds. And then here. And then if you buy a vehicle that weighs 1,000 pounds heavier than the vehicle you have now, what does your regression model predict? The amount of change in mile. So for every 1,000 pounds, the result decline is about 5 miles. So if I take 1,000 and I plug it in here, that's going to result in roughly 5 miles per gallon less. Okay? And then, so then number 11, assume the slope of a regression model is 0. Explain the correlation. What does this say about the strength? So if correlation 0, there is no linear relationship between the variables. None. 0, zip. And that's kind of how the homework goes. So we are on to 2-4. Or we just did 2-4, right? Linear regression. Ooh, we're safe now. All right, 2-5. So I'm on page 42. And a lot of this is algebra based. All right. So from the world of algebra, you've learned the relationship between slopes of a line and visual properties of the line. We need to bring those concepts forward. Okay, when the slope of a regression is positive, the line is rising. There is a positive association between the variables and the scatter plot. Okay, when the slope is negative, it's falling. When the slope is 0, it's a horizontal line. And there's no association between the variables on the scatter plot. An undefined slope is a vertical and impossible linear regression. And the correlation R and the slope of the regression line must have the same sign for the same data set. Both indicate the direction and the data of the scatter plot. Slope of the regression measures something important. It is a predicted amount of response that will take place. So they have something there for predicted sales. You have 640, 12 times the number of ads. Okay, so we have this predicted. So that's our Y value equals 640 plus 12 times the number of ads. So they are claiming that if we advertise, we will multiply our sales by 12. Okay, so if you don't advertise at all, you would have a sales of 640 is what your predictions are showing. If you had one ad, you would add 12 to 640. If you had two ads, you would add 24 to 640. 3 ads, 36, so on and so forth. Okay, so the slope itself is the change in x over, or change in y over the change in x. And so a lot of times regression models will be given to you where the slope is given to you as a decimal. Well, just take your decimal and put it over 1 so you get the change in the y direction over the change in x. Okay? And I think we're good there. The y-intercept, I'm on top page 43. The y-intercept is simply the value of the response variable, and it is associated with 0, the explanatory variable. In algebra, you substitute 0 in for x, and the y-intercept is all that remains. So in the previous example, the y-intercept is 640. This could be interpreted when 0 ads are used. We predict that we have $640 in sales. Beware, the y-intercept often produces highly unusual or even impossible interpretations. This is because y-intercept is often extrapolation. So if you consider the following ad, or average strikeouts per game, so strikeouts would be our y, or our y hat, and then we're going to say is negative 18.33 plus 0.2685, and then speed of the ball. Okay, so if you had that as your model that you were able to predict based on some sort of pitching that's taken place, this would suggest that if you threw a ball at 0 miles per hour, you have negative 18.33 strikeouts. Well, you can't throw a ball 0 miles per hour. It's not leaving your hand, so it's kind of nonsense. Okay, so many times you have to just beware of extrapolation. And unfortunately, I talked to you yesterday about the weather people do extrapolation. We do extrapolation in science. There are definitely things that extrapolation do work with mathematically. As far as the world of statistics go, it is a big kind of a no-no to make major predictions based on that. Okay, so 2-5, I want to give you the opportunity to get homework going. And friends, I'm giving you time to work in class. And some of you come by and you have blank. Let's do another work. Okay. So looks like on this page we have to use Desmos. So the least squares regression line is just the line of best fit. And then go from there. So if you need help on this, I'll wander around and help you. That's all I have. Deal?